In this video, I want to use tick and tock to time how long the hasRepeat function takes for various inputs. So I'm going to do this in a script. And notice that I have the function hasRepeat that we wrote before. I have that already in my current folder. So I'm just going to use that. Not going to care about the code. All I care about is how long does it take to run. Okay, this function that takes as input a vector v, and as output says true or false, some entry appears twice in the vector v. So how am I going to do this? Well, the key idea is what lengths of vectors do I want to measure? And I've just gone through and found some lengths that work well. So I'm going to start at 100, go up by 500, and end at 20,000. Okay, so this is going to be some vector lengths. Let's call it lengths for my vector lengths. So what you should imagine is that I'm going to test the hasRepeat function on a vector of length 100, then 600, then 1100, okay, all the way up to 19,000 and something. So how do I do it? I'm going to eventually be plotting something. So remember, when you plot, you do something like plot x, y, and then some string for the different options that you want for your plot. Okay, so I need to plot some vector of x coordinates versus some vector of y coordinates. What are my x coordinates going to be? X coordinates, let me write it down. X coordinates will be the vector length. And my y coordinates, those are going to be how long does it take. So does hasRepeat take? So that's what I'm eventually going to be plotting. And when we looked at searching a vector, we saw that the amount of time it takes grew linearly. Like if I multiply the vector length by 10, the amount of time it takes also gets multiplied by 10. But here we're going to see that it grows a lot faster. If the length of the vector gets multiplied by 10, the amount of time it takes is approximately going to be multiplied by 100. Okay, that's what's called quadratic growth. So how do I do it? I'm going to go for I in this lengths vector. And then I'm going to put that I onto my x coordinates vector. And then what do I want to put in my y coordinates vector? I want to put the timings. So how should I do that? I should start the timer with tick. And then I want to have hasRepeat evaluated for some length I vector. So how should I do that? Well, let's just do hasRepeat now for the vector from 1 up to I. So secretly I know that there's no repeat in this, but that's fine. And you always want to use the worst case scenario, or at least in general you want to use the worst case scenario. So because we had that break or that return in our hasRepeat function, the worst case scenario for what will take the longest is if there's no repeat. So this is testing some vector of length I that has no repeat, so for which our function will take the most amount of time. And then once I found it, I don't even care what b is. B is always going to be 0. Then I have this tock, which represents the amount of time that it took from this tick. So it's like, how much time did this command take? So let me store that as a variable temp, which is just some temporary variable. And then on y, I put this amount of time. Okay, and then once I've gone through all of the different lengths I wanted to test, then I can plot it. So I'm going to plot x, y. I'm just going to plot what I think shows up the best. I think what shows up the best is x marks, and with black for the color. So let's call it timing repeat for the name of this script. And now let's go back to the command window and let's run it. So it's going to take a little bit of time because some of these vectors are long enough that when it goes through the has repeat, it takes some time. So the labels on the coordinate axes aren't that important. The important thing to notice is that it's not a line shape. It's not linear. Okay, it's growing more like some polynomial. So we secretly suspect that it's growing like y equals x squared because we have to go through and check every possible pair, and that's like length squared over 2. So my expectation is that this is growing approximately like y equals x squared over 2, but then times some factor. So these numbers over here, this is like saying the longest took between 0.7 and 0.8 seconds to run. So probably I can't look at 20,000 and 0.75 seconds and notice any kind of quadratic growth. But if I plot a bunch of them like this, then I see this shape that looks like a parabola, that looks like y equals x squared.